All right, you're getting these models. This should be a P sub n minus 1 here. I don't know why I didn't put it. I know why I didn't put it, but it's not actually anything of importance. It seems like we're using this model to do everything. So is it appropriate to use this type of model for everything? The answer is no. Actually, what we did find is that many things can be modeled by this, and it's the genius of General Giordano and General Arni who first started teaching DDS here at West Point to think of a type of modeling that cadets could get into right away without having to learn years and years of fundamental mathematics like pre-calculus to get to. And so that's the beauty of this kind of modeling, is that it does capture a lot of things, but not everything. So how can we tell whether the model, this type of model, works with the data we have? Well, we take the data and we will plot it, and we'll have to look. What do we plot? Well, we let Pn be y, P sub n be y, and P sub n minus 1 be x. And if you have two columns of data where P sub n minus 1 is x and P sub n is y, then you're looking at a scatter plot of data, and the slope of that line is a, and the y-intercept of that line is d. And of course, if it's an appropriate model, that scatter plot should look linear. So how would you do this in Excel? Well, you would put P sub n from your data. If you, let's say the P sub n was the number of patients who came back to clinic visit n. And so you actually take the data from Dr. Cottom and let that be the second column. And then right next to it, put in front of P sub 1, put P sub 0 as the x coordinate. When P sub 2 is the y, put P sub 1 as the x coordinate. So you line them up side by side, and you scatter plot them, and they should look like a line if this model is appropriate. So I actually was gratified to know that this does seem the case for Dr. Cottom. This came from Second Lieutenant Taylor Brazel's thesis. She was a firstie here, and we gave her Dr. Cottom's data, and she plotted one against the other. So this is P sub n on the y-axis and P sub n minus 1 on the x-axis. And that data doesn't fall perfectly as a line, but if you cross your eyes, you can kind of say that does look like a line. Excel will give you that slope of the best fit line and the intercept of that best fit line. And so once you have the slope of the line, that's your A, and the intercept is your D. So it's pretty cool. I'm going to show you in a second how to do that. Unfortunately, these are different surgeries, by the way. So these are two different surgeries, and they do look like look like a linear discrete dynamical system would fit it pretty well. But if you look here, these aren't lines anymore. They look slightly curved. You could stick a line in there, but it definitely looks curved. So can you stick a line in there? If you ever take a class from Colonel Watts, or you ever want to do real data analysis, you go to Colonel Watts, and she'll tell you, you can do whatever you want. You can assume whatever you want. There's no such thing as a bad assumption. It's your assumption to make. As a modeler, you make that choice. So I could make the choice. I don't really care. I'm going to stick a line through this. And I'm going to let the slope of that line be my A and the y-intercept be the D, and then use that as my model. It doesn't mean that's a good model. We would say that's a bad model. And there's plenty of bad models out there, but there's no such thing as a wrong model. It just is good or bad depending on the quality of your assumption. So that would be maybe a suspect assumption to make. So I'm going to next show you how to graph your data on Excel, which is relevant to your project because you'll be doing something similar, I would guess, to estimate your A and your D for your model that you're going to develop for homeless veterans.